Welcome to Pandas Part 6. Until now, we worked with normal tabular data, but in real life, a lot of data depends on time, sales per day, website traffic, stock prices, logs, and analytics. In this video, we will learn how to work with time series data using Pandas. We will start from basics, move step by step, and end with useful insights. So don't worry if it feels new, I will explain everything clearly. So, this is a simple data set with dates and daily sales. Each row represents sales for one day. And this type of data is very common in business and analytics. Here we first import pandas as PD. Then, as we always do, we need to import pandas because we are using pandas here. So before starting the code, we import it. Then we created a dictionary. If the dictionary has more, this is our key, and if its value has more than one values, then we should separate it with commas and also place it in square bracket. We name the variable as data here. Afterwards, we move that to df and we call df. So df is executed. This is a simple data set as we see here. Now we are moving to date. Here we place date in strings. So the date column is currently a string. Pandas cannot perform time-based operations properly on strings. So we must convert it into date time format. Before that, we can just know its data type. So df dot date types and run. We get date as object. So date is not an integer. We checked it. Now we need to convert the column to date and time. So here we are going to convert this column to date and time. So I'll just mention this here. And if df date, our column name, and then we are placing it to pd dot to date time and open a bracket df date. And we need to check whether the data type is changed or not. So now pandas understand that this column represents dates. This unlock powerful time-based features. So now it's in the format date time 64 ns. So it is no more object, but in the format date time. So for that, what did we do? We placed the date in a square bracket with the df and pd dot to date time. It's just like English. We just need to learn it as English. Because of that, Python is so much simple. And here we again took df date to here, but with a bracket. So now we converted the date column to date time. So now we want to set date as index. It is a very important step here. For that, now we are going to set date as index. And for that, we just df dot set index, then place date, separate it with a comma in place. So in place, we give true, then we call df. So when we work with time series, it is best practice to use the date as the index. This allows easy filtering, slicing, and resampling by time. So we just get it in a correct format. Before this, it was indexed like this, but when it comes to here, there is no index. Okay. We really set date as index here. So there is no separate other 0, 1, 2, 3 and all. Okay. Now we are going to access data using dates. So we are going to access data using dates. For that, how do we do last time? We use a function that is, we use log as the word here. We can take it as location. So it will be much more helpful for remembering. So accessing something, we can use a code log, that is df.log. We are accessing a date 2024, 01 and 03. Let's access it. So we get sales 300. Now here we can just look here where is 2001-0103. Here it is. So by accessing its date, we access the sales 300. So to know the location of something, we just call df.log. And with the square bracket, we place the index. Here we change the index numbers to date. So because of that, we placed date here. So we can also select a range of dates easily. This is extremely useful when analyzing specific periods. Now we are going to add a new column. We need to add a new column. Okay. Now here we are giving the column name df dot. We don't want dot df daily growth and equal to df sales dot diff. So the diff function calculates the difference between consecutive days. This helps us to understand daily growth or decline. So let's run this and understand what happened here. You can also print df. So we get another column that is daily growth. And here the daily growth. So what did the diff function do here? It calculates the difference between the consecutive days. If the days are 1 and 2, when the days are near to other, means 1, 2, 3, 4, when the days are consecutive, it calculates its difference. It just subtract it from each other. Okay. So when we subtract 200 and 350, we get 150. So such a way the process goes. Okay. And it's all really subtracted it from 350 minus 200. Okay, because of that we get 150. Okay, so for the first one we don't want any subtraction. Because of it we give an and here. Now we need to change the percentage change. So for that what we need to do, just like before, df percentage change, we give it and give a equals df dot sorry sales, then dot pct change and bracket with star and 100. We say asterisk, but here we can say star. That's fine. So percentage change shows how much sales changed comparatively when the from the previous day, and this is widely used in business and to find business reports and financial analysis. So we understand by .pct change, that is percentage change. So for percentage changing, we also add 100 because we use 100 while calculating the percentage. Okay, the code is PCT. We can P, C, and T, the first and the second word, and the second letter. Okay, so we can understand is PCT change is for percentage change. Now we get the percentage change in each of the rows, and we are moving to resampling data, the core concept. Um, For that, we can just mention it. While you go through in this, you can understand what we are doing in each line of code. So, resampling data allows us to group data by time intervals. Here, we group sales every 2 days and calculate the total. So, df dot resample, just wrote the word with 2d and dot sum. So, group data by 2 days. This is what 2d means. So, here we grouped data by 2 days. Why do we do this? This will just group data by time intervals, and we group sales every 2 days and calculate the total. So it's the sales of 2 days sales. That is from, you can just check DF here. Now we can see it is the 2 days. That means 200 plus 350. Then we get 550. This is how grouping data by 2 days means if it's 3 days, what will be? So now it that's cut out to 850 and 1230. So it calculated as per the 3 days. Now we can resample weekly. For example, um, I can add it to. So df dot resample and we gave a capital W dot mean. So this calculates the weekly average sales. Resampling is powerful tool and it's used for trend analysis. Okay, so we get the weekly average sales. For that we use mean with W, which is weekly resample. Now we are going to rolling windows, the trend smoothing. So I can add this too. And df dot rolling, I guess average 3. We can place it in a box. I'm sorry. Equal to, we always use sales here. Sales and just add dot rolling with window equals 3 and dot mean. Then print df. So, rolling average smooths fluctuations and highlights trends. This is often used in analytics for forecasting. Okay, so we get all these things, and it shows average smoothing fluctuations and highlight trends. Okay, and find the best sales day. How do we find the best sales day? We can do this. Find the best sales day. Here, TF dot. Oh, I'm sorry again. Here, sales dot ID max. We run. Hmm. Actually, we just Mr. X here. We can add it and then do. So we get a timestamp from 1st January 1st 6. Okay, and this tells us the date with highlights highest sales. And small insight like this are very useful in decision making. Maybe more here we can look which is the highest sales, and we will get the answer for that. So here, 2024 106 has 450 as the sales, and we get the output here. So through IDX Max, we will get the highest scales, and small insights like these are really useful while we are taking a decision. So before entering the code, we need a basic visualization. So for that, we can import matplotlib. Dot pyplot as plt, and then we can say tf sales dot plot, and we can name the type means give the title as um, daily sales trend. Plot dot x label as date, and plot dot y label as sales, and plot dot so. Now this is simply a line chart help us to visualize, understand the sales trend. We are only visualizing the data, not learning matplotlib deeply yet. But from this, you can understand how simple these all codes are. We just import the matplotlib library, and we place plt as the short form here for easiest code and reading. So whenever we write something, we add it short form plus a dot. Yeah, that's so simple, right? So whoever is starting this can easily learn this Python, especially Pandas, which has short codes, and we can learn this. Okay, so we get a line chart that visually understand when is the best sale, and with the date, replace date 6 and 450. So as we all learned about graph, we know how to check all these things. So when is the lease sales? The lease sale happened in first 2000 Jan 2004. So from the graph we can understand all this. So in Pandas part 6, we learned how to work with time series data. We converted dates, indexed by date by time, accessed date ranges, calculated growth, resampled data, and analyzed trends. Time series analysis is a critical skill in data science and analytics and real world projects. So in the next video, we will apply everything we have learned so far in some practical Panda project. So thanks for watching. I will see you in the next lesson and happy new year.